Assalamualaikum and very good morning. First question, can you all hear me?
Yes, Doctor.
Yes, Doctor.
Thank you. Wait, Okay. Before we start, as usual, please submit your attendance. If you encounter any problem, let me know. Hopefully, there is no problem. Okay. So for this week, we are going to continue to the next diagram, which is called sequence diagram. Right. So basically, previously you have learned use case diagram and also class diagram. So you know that by now, use case diagram meant for functional requirements, the functionality of the system, and the class diagram meant for the structure of the system. So you can see that how different use case diagram from class diagram. So next is the interaction. You know that when you develop use case diagram, next thing to do is you have to describe your use cases. So when you describe use cases, it involves flow of events, alternate events, exception events. So all of this actually you can depict as a diagram using interaction diagram. There are 4 types of interaction diagrams. We call it as a sequence diagram, interaction overview diagram. We have active communication diagram or activity diagram, and another one is a timing diagram. So for today, we are going to look at sequence diagram. So as usual, we have to look at on how to develop object interaction. Then what are the messages supported by the interaction diagram, and how to model object interaction. Okay, so this is how a use case diagram looks like, right? You know how the actor looks like, and then you have a use case. So how to develop object interaction from use cases. For example, this actor, let's say user and able to log in, right? So you have to explain how the login processes will go. Okay, from the processes, from the events, you have to figure out all the structure or all the objects involved during login process. So you will extract the flows using classes as you can see here in the slide. Okay, so you have actor, we pass the message to the first class, second class, and lastly to the third class. So basically this is how the sequence diagram looks like lah. But then to go further, let's say we go another example, register account. Customer can register account, that's common. So how the customer can register account? The customer has to select register button on the, let's say, account registration page. Okay, and then from that page, the customer will click the register button and then register, key in the information required to register himself as a customer. Okay, so once you have entered all the information, what will happen to the system? You will, let's say you key in name, address, your salary, for example, and any information, and then after that you click save button. Once you click save button, what happened to the system is all the information entered will pass to the database. This one we call it as the store information lah. Okay, upload information to the database. So this one it will involve another a table in the database system. For example, here they got account, okay, an account as an object for account class. So you can see the flow goes from the customer select register through a class name called account registration page, and then the customer will key in the information through a method register account, where that register account exists in the class called customer. And then once the customer has entered the information, the information will be stored into a table called account. So you can see here there is a if you look at the account registration page, you can see there is this entity, they call it as a boundary, and then this one as a control, and this one, another one is a table. Alright, so you must know this because in the last class, we always focus on the control and the table in the database. Alright, but you have to remember when you develop a system, there are few interfaces must be developed. If not, the end user cannot do anything to the system. A user must through some interfaces in order to interact with the system. So this is why we have this. We call it as a boundary. Okay. So after you've already figured out all these classes involved for that particular use case, next thing to do is you have to know all the messages. Messages basically the methods in the programming. Okay, a message is the information being sent between two objects, within an object or within an object. So it doesn't mean it has to be between two objects, but also within an object. Within an object, for example, recursive function. Okay, here we call it as a reflexive message. Okay, so you can see here, alright, at the pass message 1 to class 1, and then message 2 and message 3 will pass to the class number 2, and then message 4 will pass to class number 3. Class number 3 will return back message 5 back to the class 1. Okay, never mind, we'll look into the example. Okay, so before we go into detail, let's look into this. Alright, what we are trying to learn actually is the 3-tier sequence diagram. It's a very detailed of interaction between classes, because we have gone through a class diagram. Okay, but actually there are 3 types of sequence diagram. They call it a system level sequence diagram, subsystem level sequence diagram, and the 3-tier sequence diagram. Most of the time we're focusing on the 3-tier sequence diagram. Where you have to draw a sequence diagram, it's always about 3-tier sequence diagram. Okay, so because the subsystem is just to show the interaction between the actor and the subsystem. Okay, that is why some projects, okay, you provide the subsystem, you draw it in the form of module. Remember in the use case diagram. Then in that situation, that group easily convert their use case diagram into subsystem level sequence diagram. For those groups who do not provide that module, the sub module, then you cannot develop the subsystem level sequence diagram. Okay, the list that you will have is 2. One for the actor, one for the user, regardless of whatever user, customer, it can be deaf mute, it can be patient, right? And another one definitely for the administrator. Some call it administrator, some call it as a manager. Okay, that one at least you will have two. Some of you got three. I don't expect you have to go four. That will be too big for a project. Okay, that is a for subsystem level sequence diagram. Another one is the higher level, the abstract level. We call it the system level. It's just between the actor and the system. Okay, so basically we don't get so much information from these two level, system level and subsystem level. That's why when we talk about sequence diagram, it's always about 3-tier sequence diagram. Okay, so here, okay, before I go the next one, you can see that there is a lifeline here. They call it a lifeline. So lifeline is basically this thing lah, this rectangle. Okay, this dotted. Okay, never mind. Okay, first we go for notation, how a sequence diagram looks like. Alright, first it consists of an object. That one is compulsory lah. It's a basic notation of any sequence diagram. First, you must have object. Object is in the form of like this. Alright, so if you do not have object, at least you will have a class without the name lah. For example, in page, just like that. So it's common lah, like this. Then go to customer table, something like this. Okay, you must have an object. Okay, and then right, next is you have to know what type of object that you have instantiated, because you know that there are 3 types of classes. Is it boundary, is it entity, or is it control? Okay, so because from here, then you know whether your sequence diagram is complete or not. Okay, and then next is a lifeline. This one is compulsory. If you talk about sequence diagram and you only have classes or objects, then without lifeline, it means you only have a class diagram, right? So sequence diagram, you must have the objects and together with its lifeline. The lifeline is just a matter of like this lah, the dotted line, okay, the vertical line, okay, dotted line. So lifeline represents the existence of life of participant within a collaboration to realize a use case or an operation. Okay, so it's life, how long the class live for that particular operation. Okay. Alright, so other than that, in the sequence diagram, you will have actor. Actor exists everywhere, okay, because we want to see how it interacts with the system. Okay, wait, my network slow, I guess. Okay. Alright, so I don't have to repeat this. Basically, actor in any diagram is still an actor. Same definition. Drawn as stick people with a name. Okay, so please avoid using user. Right, some of you put user in your use case diagram where actually you know that it's meant for mental health system, it's meant for deaf mute or political system. So you know who are the people, all right? Worst scenario, we put public. There is some system that there is no such thing as a specific one, okay? Because the statement represent the role of a system or the people, okay? So the definition is still the same. right? And then next is about the lifeline. Okay. So you know that the lifeline is like this. Alright, okay, that is a lifeline. So on the lifeline, there is a focus of control. We call it as a focus of control or activation. It indicates time of an activation when first processing is taking place within that object and the operation is waiting for a return from another object. So that one, you will draw it something like this. I have to make it big. Okay? So whether you want to share the box or not is up to you. For me, you don't have to lah. It's a wasting of time. Okay, this one okay, or this one also okay, right? Basically, it's a focus of control. So when you look at this example, we have two classes, class 1 and class 2. Class 1 pass message 1 to the class 2. It means operation processing is taking place within the object and operation is waiting for a return from another object. This one is still activated because it's waiting for message 2. Okay, so that's why it's still activated. So but this one, once for class number 2, right, if you look, the activation is up until here because that is the last process, that is the last method involved. So once it's passed to the class number 1, then it's done lah. Okay, so that's why it's live. The activation control is up until that level. Okay, so this is another example. So focus of control or activation represent the period during which an element is performing an operation. If the use case requires actor interaction from the beginning to the end, then actor has to be activated all the way. So you can see here the actor focus of control is activated until the end, right? Because actor will give something and receive something. But then once he gives something, he has to wait all the processes that involve a lot of classes until he receives something. Okay, it's just like login. The user key in ID and password and then click OK. So by clicking OK, it involves a lot of another processes. Go to the database, checking whether it's correct or not, and then maybe it's not only that, maybe you have like encrypted the password first before checking to the database, and then once it is okay, it will pass to the user a home page. They go to the next page. But then to go to that it has a lot of processes lah. So that's why actor focus of control is activated from the beginning until the end. Okay. Okay. In general, there are 5 messages in the sequence diagram. Alright. So basically, they call it as a synchronous message, asynchronous message, reflexive message, create message, and destroy message. Okay. So we go to the first basic simple one where all sequence diagram must have, which is synchronous message. Synchronous message is if a caller send a message, or we call it a synchronous message, and it must wait for a written message in order to continue processing. That one we call it as a synchronous message. For example, it's like this. Okay, so when you have this object class, pass a message to here, to plus number 2, and the notation is like this. Solid arrow with full arrowhead. That is why when you draw your use case diagram, if you use draw IO, they use this arrow to represent the extend and included, which is wrong. And you know that include is always like this, right? But then I know that when you use draw IO, it's hard to find this arrow. So you use this. Oh, sorry. You use this. This one is wrong. This one represent a synchronous message in sequence diagram. Okay. So what you have to do now is to re-edit your use case diagram. Because when I explain it to you, you cannot understand. So now now you understand why I told you, I understand the draw, do not provide, but actually it's not correct. Another worst scenario when you involve inheritance. For inheritance, some of you do it like this. Some of you, let's say for actor, they use this. I understand because you use draw IO. However, it is wrong in the use case notation. It should be the blank one. Okay, it's always like this. Because when you use this, this one represent this in the sequence diagram. It's a synchronous message. Okay, so back to the synchronous message. Synchronous message is where you have a call message and then it needs a return. Okay, reply message. A reply message return the control to the object that originated the message. Reply messages are shown with a dash arrow. Okay, it is optional to show the reply message as synchronous call message. We always have to reply message. So the return is like this. Okay, this is what we call it as synchronous message. So this is another example lah. This is another example where you have call message, call, and then you return. This one return. It's not necessarily you go and then this. And then you go, not necessarily. Okay, so this is another example. Alright. But then if you notice this one, this is open, this is closed. This one closed, this one open. Closed means is a synchronous. This one is asynchronous. The difference between dia tak go to the next slide. It doesn't go to the next slide. So while waiting, it goes to another slide. Okay. What we are looking at now is a synchronous message with the full arrowhead. So there is another one, we call it as a asynchronous. So asynchronous does not need reply message. Okay, you just call without the return. You can see on the next slide actually. But then this one, they hang a little bit. So wait Okay. Alright. So this is what I'm talking about. You in another slide you can see the example. Alright, from the actor send a message, okay, call message, and then that one is synchronous, and then go another message, and then from class 2 to class 3 there is a message 3. However, message 3 does not require written message, okay, reply message. So that's why you can see the arrow is an open arrow, it's not the closed arrow. Okay, and then once the class 3 has done the message 3, it will return it will return message number 4 that straight away go to class number 1. Okay, so this is another example of a synchronous message. So on the next slide is an asynchronous message. An asynchronous call message can continue processing and does not have to wait for any reply message. Therefore, the operation in both objects may carry out processing at the same time. Okay. Another one is a reflexive message. Okay. So for the reflexive message, it's called by itself. Alright, this one. Hilang. Actually, just like this. You have an object or a class, and then you have this. Like this. Okay, that one is a reflexive message. Okay, this the closest example I can tell you is a recursive method. Okay, but this is not necessarily recursive method. There are situations where your class has so many function that actually processing inside itself. You know, especially if it involves like machine learning algorithm, you know, all of this is actually within the same class. So it's passing through everything inside them first before return something. So that one is another kind of reflexive message. Okay. Another one is a create message. Okay. For create message is a little bit different. You can see the location of the class. This is a common one, the one that you have looked at before, right? When you have create message, it means that the object or the class is created later, right? When you have a use case, you know that there are some classes involved, right? However, all these classes must be there in order to operate that use case. Okay. However, there are certain situations, especially when it comes to alternate flow of event. In certain situations, only this class will be created. Okay. So certain situation, sometimes it happen like after few steps, after you gone through all some classes. So that is why it comes later. Okay. This is a create message. Another one is destroy message. Okay. Destroy message is a little bit different. Destroy message is more like you have to put X at the end of the activation. Put like this. So this one is a destroy. We call it as a destroy message. There are some questions asked like, doctor, isn't it like all classes will destroy at certain point? You are right. However, we do not put X to all classes. We only put X only on certain classes where it destroy at certain time, and it must be destroyed. Even for example, like delete, okay, or disrupt. It must delete. It must be distracted. What happen if you do not put X? It means that it's still running. It's still there. Okay. It's just like you have a class customer. Okay. Class customer is always there. Alright. You will not destroy the class customer unless you call a delete function and it will call specific table. Then this destroy will be you need to put this X. Okay, that is a destroy. Destroy message. So far that's all for sequence diagram. Notation. We go forward. So basically what I can say is for sequence diagram you must have classes. Alright. Initiated by actor. Okay, so since we are doing three-tier level of sequence diagram, we are going to have a lot of classes. All right, very detailed, where all of this, you must cover boundary, you must cover control, you must cover the entity. Okay, so next is you must have Lifeline, all of them. Okay, you must have Lifeline. If you do not have Lifeline, it means you are not drawing sequence diagram. Okay, next one is okay, I annotate something lah. This is Lifeline. Okay, next is the flow of control, the activation. Okay, this is the activation. So the activation, okay, so this is what we call it activation. Right. The next one is about message. Okay. So for messages, You can have synchronous. You can have asynchronous. You can have reflexive. Okay. You can have create message, and you can have destroy. At least you must have this. This is basic or compulsory. Alright, for synchronous. The rest is depends. Okay. So how does it looks like? It looks like this. Okay. That one we call it as a call message, and then it has reply message. Okay. So we can also have asynchronous, something like this. Okay. Asynchronous is a open. Example like this. Let's say lah. Alright. And then you can have okay. This one let's say lah. Okay. So that is asynchronous. Reflexive, maybe you have something like here. Okay, it called by itself. Okay. Create. Okay, create is another one. Create is something like this. And then you have, sorry. And then destroy. Let's say, example. Okay, create and destroy. This one's usually when you have create, you will have destroy because it happen like, you know, somewhere in the middle. Okay. Okay, Omar asks, can actors send reflexive message like WhatsApp your own number? Even to WhatsApp your own number, when you key in message, right? And then what's next? You click save, right? You send to your, regardless, let's say Telegram, you save to yourself. It still has to go to the um it has to go to the server, it has to go to its own table, it has to, like, you know, WhatsApp is even encrypted thing, blah blah blah, uh, and then you know it's safe lah. Okay. So sending message is not like by yourself. When you type in, you are start using a system. So it means there are so many classes involved already. Okay. The head of the arrow, there are two types. One's synchronous, another one is asynchronous. Synchronous is the full one. Usually we use the full one. That is common. We send something, we want to receive something. We send something, we want to receive. That is a common. That's why I say it's a basic synchronous. Asynchronous, you send something, but you do not expect any return. Okay, for example, you have like you log in, and then nothing happened. You key in ID, password, okay, that's it. There's no home page, there's no say you are successfully logged into our system. There's nothing. It's just blank. That is asynchronous. Oh, because okay, Daryl Beckley asked why the third one, because it means that it activated at the beginning. I want to show you this because it doesn't have to be like one after another. It could be once this one, let's say, for example, what? When for login, okay, face activation. Face activate, you want to log in. Okay, you want to log in. Now we can have this face ID, right? So sensor is already there. It already activated whether you want to use the face ID or not. But then your system is about customer wants to log in. But then now, if you are logged in through iPhone, you can have face activation. So the sensor is already activated. But then when you log in, or you don't want to use the face ID, you still want to key in the passcode, but then it's already activated. So that is how that is why I put the third class, the activation, right at the beginning. There are some situations it's like that. Do we need to create message arrow from activation to the created class? Yes. Then what's the point of having that class? You have all these classes because you're going to call them. When you call them, it means you want the class to be, you will use that class. All classes, okay. Generally, all sequence diagram initiated, started with an actor. Okay. However, there are situations where there is no actor. Not necessarily you must start with actor. No. For example, let's say extended use case. Extended use case. How do you describe your extended use case? It is activated by the base use case, right? The one that I asked you to redo. For those who use extend include, where exactly it is triggered. It's not triggered at the beginning, it's triggered somewhere in number 3, step number 4. Some of you put it as an alternate, some of you put exception, and then you go to another use case description. That use case description, the actor, of course, it comes from the one you use from the base class. But the process, the main flow of that use case, it got nothing to do with that actor. Right? Then in that case, your sequence diagram, this one PIC and there is one specific person to do sequence. That sequence diagram not necessarily have actor. You will start from class all the way. How to know the length of the activation block? Okay, let's say for this example, actor call the first class and then it will return. Then that's it. We use that only. Then it's end. That's all. That's why it's activation at that level. And then the third message go to the second class, and then it start, right? And then we go. So it still activate. Send another third one, and then that's it. because for second class do not return anything. So then that's it lah, end. Okay, and then it goes to the next one. However, my example here, I purposely put the third class from the beginning to show you for the situation where this class activated regardless other class has been called it or not. It must be activated. Okay, for example, the example I give you lah, the sensor one. Okay, any other question? Can we use create message for extend? I don't understand. Create message for extend. Oh, the last number 4, class number 4, that one is created because of extend use case, is it? I don't understand, Lim, your question. Okay, Lim, for extend use case, you must have a sequence diagram for that. The rule is like this. How many use cases do you have in your use case diagram? 12, 14, 16? I think the most I saw is 16. I'm not sure. So it means that you must have 16 sequence diagrams. Okay. Okay, that is a good question, Ahmed. Can sequence diagram have a class that is not in class diagram? Cannot. Okay, what happened here is like this. You have you done your class diagram? Not yet. Oh, not yet. Okay. Alright. For your project, if I relate with your project, after you create your use case diagram, you will have class diagram, right? And then from class diagram, you go to sequence diagram. It's just like in our class lah. So while developing the sequence diagram, you realize that you need so many extra classes. Because once you develop a sequence diagram, you start thinking as a developer. Okay, so then you realize that there are some classes actually not in the class diagram. Then you have to redo your class diagram. You must redo your class diagram. All classes that you use in sequence diagrams must exist in the class diagram. Full stop. That's the rule. Okay. Any other question? No. Async no written. That's why we call it async. Asynchronous. Asynchronous has no written. Okay, let's go to the case study. So this is a simple case study, register e-wallet account. Okay, so that is your use case, you have done that. And then that is the main flow and exception flow. Okay, so main flow, the customer clicks register e-wallet, and then the system validate if e-wallet being registered before. And then in this case, you have exception. If the customer has registered, system display, you have registered e-wallet, thank you. And then the third one, the system searches the account for email and username associated with the customer. The system register the e-wallet and the system display, blah, 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 on the e-wallet registration page. So from the main flow, first, you have to figure out what are the classes involved, right? So you can see that you have e-wallet registration page, right? So that one is a boundary. And then you got e-wallet, another class, okay, and etc. So this is the thing that you have to do lah. Next slide. Okay, so what are the classes involved, right, or objects? So you have to list down and then you have to figure out what type of class. Is it boundary, control, or entity? Okay, so I just go through this one. So you can see here, the customer clicks register e-wallet button on the e-wallet registration page. So the object is the e-wallet registration page. Okay, so when you say about page interface is very straightforward lah, you know, it is a boundary. Okay, and then you validate. So the system validate if the e-wallet been registered before. So this one involves some kind of algorithm, if else, you know, something like that. So it's a control, right? And then the system searches the account for email and username associated with the customer, right? So the object involved is a customer account. So to check whether the customer already registered, right? And then that one is a entity, it's a database table. Okay, and the system registers the e-wallet, this one e-wallet again, and then the system display, this display is about boundary, so e-wallet registration page. So from here you have to draw the sequence diagram, right? So you have customer, e-wallet, just go to the e-wallet registration page. The sequence of the class is very depends on your main flow. Okay, it's easier for you to draw the arrow lah. Next. Okay, and then you annotate each class with its type, right? This one is a boundary, this one is a control, and then another one is a entity. And then you can see that the message pass, the customer select, register, and then display message. Okay, and then from the e-wallet page to e-wallet, validate customer and register e-wallet. And then from e-wallet class to account class, you have search info and reply info. Okay, so all of these 6 methods basically are messages in the sequence diagram. Okay, so how to draw that? Okay, this one is in the class diagram lah. It's, you just put the method inside the class. Alright, e-wallet page consists of register e-wallet button method, display message method. Okay, and then e-wallet has validate customer method, register e-wallet method. So same goes to account. So however, in account, we mentioned in the main flow, the system search account for email and username. So that's why you have attribute there. Okay, and then you know for class diagram, you have relationship. So that one, yeah, you draw lah the association. Okay, alright. So next is to translate that class diagram into sequence diagram. So you can see here, you have e-wallet registration page, right? Exactly the same from the above. And then you got e-wallet exactly, and then account exactly from the class diagram. And then you have registration e-wallet button. So registration e-wallet button, who will do that? Is the customer. So that is why it comes from the customer to the class. Okay. Even though register belongs to e-wallet, it comes to that class. If you look at, there is another message, we call it as a display message. So that display message is different, is here. Will be received by the e-wallet registration page through e-wallet. But then who will display display message is a e-wallet. Okay, never mind. I go one by one first. Okay, first is a register e-wallet button. Okay, it belongs to e-wallet register. And then you know that once register, it will go to validate customer. Okay, validate customer. So validate customer belongs to e-wallet. So that's why it's here. Okay. So validate customer. And then once it's validate customer, e-wallet validate the customer, what happen is during that process, it will check the account table. Okay, search information. So it will search info, see the search info through the class account. Okay, this one is the call message. I'm explaining the call message. Right, and then you know that there is another one, this register e-wallet. So once it has search information, and then it will register to the e-wallet. So this message will read as a return. So in another words, in a class, you have many methods. Okay. However, it divided into two. One is it for call, another one is it for reply or return. Okay, so this one, this register e-wallet is for reply, and validate customer here is for call. So you can see this one. Let's say if I want to talk about e-wallet, it has this. Yes, this. Okay. But then you know in real situation, you have many. You do not have two, you got many. So it depends lah, how many. You can have something like this, reply info, search info, this one kan. I'm not sure how does this reply info looks like. This reply and search info actually is here. Maybe it's here. It's not necessarily one direction, one message passed to the other class. It can be many classes, many messages, many methods, not necessarily one. Okay. So that is how you translate from class diagram to sequence diagram. So next question is, are all methods must exist in the sequence diagram? Oh. Macam tulis ni. Are all operations, what do you call it, operations or method must exist in the sequence diagram? If you have, like say, in one class, you got 10, not necessarily you must have all 10 in the sequence diagram. No. In the real implementation, you need all these 10. However, you cannot really depict, illustrate through the sequence diagram, but it's needed for, you know, as a programmer, right? You sometimes you need extra method, blah, blah, blah. Not necessary. This one is just the one that you can show the interaction, whether people can understand, not as detailed as to that level. Okay? Any question? Oh, baru pukul 10. Sequence diagram is quite not that hard. It's very straightforward. How to draw a sequence diagram that involve multiple actors? Good question. You draw both, like this. Like this. I cannot draw. Why? Can I? Make it big. Like this. Let's say customer and let's say customer and admin can log in. Customer and admin must register to the system. And another one is log in and for login, we have the situation where customer and admin must log into the system. Functional requirement number 1. So for this case, because it's very, you have to know customer and admin, is there any big difference except for the data lah, right? Different data. Okay. So in that case, you just choose one. Choose one. Juga lah penyebut ni. Yes. Letak sini. Okay, sebabnya. Okay. Okay. Why? Because same operation, same flow lah. Same flow. There is another situation where, let's say, both log in, customer and admin log in, but then they go through different process, different classes. Then you must have different. You must have something like this. Let's say this one, customer. This one, login page for customer. Then you make it separate. This one, different classes. Okay. Any other question? So if you have no question, let's continue. Break kejap lah, kan? Break 3 minutes. Okay. We are about to learn after this to cover the exception. Oh, tak ada lah lepas ni. Next slide. Next week lah, sorry. They have alternate, they have loop, they have to represent if else case, all the programming things lah. Oh, dah habis dah? Oh, that's fast. Every method to the left direction, a return. Oh, not necessarily, Chen. It must be, okay, to the left direction, the return. Not necessarily. there are situations where it's not a written message, but then how to say, the next step is involve classes that you created before. So it goes back because you cannot have uh, two times. You draw same class more than once. You only have one class exist in one sequence. Let's say you have customer, then that's it. You cannot have customer at the beginning and suddenly at the end you have another customer. You cannot. Alright, so sometimes there are situations where you have to pass information to the a class where you already created at the beginning. So the arrow go back, not necessarily. Let me share you this one. Lifeline, the dotted line, right, is the same. It's the same length lah. If you have a lot of operation, then you have, it's very long. But then the difference is the activation. You all tak baca the previous notes You all kan ingat saya dah start. This one I just want to share lah. It's nothing. It's not part of the lecture today. This one from the previous notes I already uploaded way on the first week. Kau tak tengok kan? We change it because there are some errors lah. For example, this one, the actor is wrong. It should not be that stick. That one is weird. Ta-da! This is example. Okay. You can see it's a little bit weird then. But then this is how it looks like. So the sequel, because you are not learning all the things yet, so actually at the end it looks like this. It must be in the box. There must be a label there, SD. What is the name of the use case? Right, this one add a new advert to campaign, and then we start with the actor to normal lah. Alright, and then you have this activation control, and then you got client campaign advert, and then pass message. Okay, so the pass message we don't put in the bracket as a method because it's not confirmed yet. It could be get name, involve many methods. This one is a message passing, right? And then there is a loop there. Okay, that the box loop means is a for loop lah. For alternate, we have alternate ALT. Okay. And then we call it that one is an interaction operator. And then we have create object creation. So you can see that the advert message, the last one from campaign to new advert, is not the fine line, the full arrowhead. It looks exactly like a reply message, but it goes to the right. It's not going back to the left, right? Not necessarily, because it's a reply. It's a advert is a reply message from add new advert. And then once the campaign manager wants to add new advert, then new class is created. It's a reply message from them. Pening lah you all. This one is explanation. I show you another example. Synchronous. This one's simple lah, synchronous. See, boundary lifeline, suddenly it exists over there. Then the question would be, doctor, why it goes down, not up? What? I also do not know. I have no idea, don't ask me that question. And then we also have object disrupt. This one is a teaser lah for next class. Next class we will cover some of this, and we will change some of this as well, so that hopefully you can understand more. Suddenly it got black. Shading. We will not use network slow There are things like, we will cover all, but we will improve we will improve the slide. Hopefully you can understand. This one is a different kind of sequence diagram. It puts shading in the activation. You don't have to shade this. You don't have to shade this. Reply message. This is the one alternate. This is the alternate. Then you have to put the rules, the condition. It is if there is too complex, instead of putting all the operation, you just put reference and go to another one. So because this semester I'm not involved with the notes, Dr. Hazrina, so it depends on which part that she wants to cover. This one is the asynchronous message. Asynchronous message it's not really explained detail just now. Asynchronous message, you know that it does not return anything, but actually it's more like It doesn't wait to have written in order to activate. It keep on, let's say for class A, class B, this one, right? It send signal E, and then class B will return signal F. But this is not one after another. At the same time, while class A is sending signal E to class B, it also sending signal X to class B. That is what is trying to say. But then it's not like exactly at the same time. It could be at signal E T0, but then signal X at T3. Signal F is not sending yet. Signal X is only received by class A at T10. Something to do with this. Lower down, the downline means more time pass. Oh, no, not necessarily. Because we also have parallel situation, right? Same time situation. Signal, correct. Because when you say at the same time, it means that at T0, signal E and signal X will be sent, right? Correct? But that one is parallel. That one is okay. But there is a situation where signal E sent at T0, but signal X sent at T3. It's not at the same time. Alright? Why this one asynchronous? Because the receiving message is later on. Kenapa saya batuk? Spend zaman-zaman COVID ni batuk. Signal send at the same time, yes, it's possible. But we call it as a parallel. Parallel is not like this. Parallel is different. Parallel. This one interaction operator. Parallel is different. Mana? Tak ada pula. Because I love that question, parallel question. We call it, that's not example. This is different, that one different. Parallel is different. Are there parallel? Box number 4, par. We got alternate, option, break, par. Par is parallel at the same time. So most of you has this sensor lah, or this whatever the project. They got a lot of real-time system, right? So this one is a parallel. Par. Okay, you will use this. That one is very simple. Just use the box. Wait, where is the box? It's not moving. I go to the next slide already. Continuation. Open continuation. Oh, I know what I tried. Okay. Ada? This one is alternate. If else, you put ALT. If parallel, you just change to PAR. Then it become parallel lah. Same spot. It's like that. I don't understand what do you mean by same spot. Okay. Alright. Very good question by everyone. Okay. There is a few slides left. About the resilience of the system. Okay, right. Okay. So, alright. Yes. It means actors send messages to multiple class at the same time. Not necessarily actors, from class as well. The process sent to not necessarily different classes. Same class, different class, but the process at the same time. Then you use par, you put par there. Okay, let's continue. Resilience of system. Okay, what is exactly this slide about? The highly resilient system has an appropriate distribution of responsibility among classes. Therefore, change in real-world requirement does not produce greater magnitude in terms of change of the system. An application that is highly resilient costs less to maintain, which means easier to test and to maintain. Okay. So what does it mean? For example, let's say we have same case study, rotate a shape and place sound a shape. Okay. So if you use procedural programming, it will look like that. Okay, all the method inside one program code. But then if you use OO, you will put all this rotate in class. So you will have different object, alright, according to the parameter lah. Okay. It's a new class for each object. Okay. So for example, let's say we want to use same case study. Right, the customer clicks register e-wallet. Okay. And then second, the system validates if e-wallet being registered before. And then etc. It's the same thing lah. However, what we want to have here, instead of e-wallet, if you look at the class diagram, instead of we have 3 classes, we have 4. Why? Because we want to have a very thorough validation with all this algorithm to ensure that the customer is a valid customer, right? To ensure it's a valid customer, right? So in that case, you can take out the validate customer that comes from register e-wallet before as in a form of operation, and it become a class. Okay, so in that situation, you will have a class name just meant for validate customer. So obviously the class type is a control, right? Now you have 4 classes instead of 3. So when you have 4 classes, then it will change your sequence diagram. Okay, So you can see that instead of from e-wallet registration page to register e-wallet, you go to validate customer first. Okay. Usually when you say that validate customer, is always about method, correct? But then in the real situation, you as a developer actually, when you go to higher level, even next year, third year, you will realize that every time you go to complex algorithm, you will create a class just for them. Okay, so you will not mix up that complexity, this algorithm with other classes. I always relate with the machine learning because now we are in the machine learning era. Okay, so when you develop a machine learning, okay, for a particular system, your system has their own classes. For the machine learning itself, whether you want to adapt or adopt, you will have another class for it. Okay, so that is why now the easy way to do machine learning is you just call a library. Right, a library itself is actually is in the form of a class. All right, if you go to SVM, for example, what is SVM? Vector machine. Okay, naive Bayes algorithm. If you manage to go to naive Bayes algorithm, you can see that the code has a lot of classes inside that, and a lot of methods. So what does it mean? It means that you cannot simply develop NB just inside one's class. It's a separate entity, it becomes a separate control where you, a lot of complexity. So same thing goes to validate customer lah. So I think almost all of your projects, almost all of my students, group 1 until 5, has machine learning in your proposed project. So you must, it means that you have control. You must have control classes in your sequence diagram that represent the machine learning part. I'm not sure how. It could be as simple as you put just their machine learning. If you, then I know that you don't really understand what you mean by machine learning. If you have more knowledge on machine learning, you will have some kind of classes lah, to show that, oh, it goes to this one API lah. You with the that I know, oh, this group understand what does it mean machine learning. But I don't mind. But the point is, for this class, we are not learning machine learning anyway. The point is, all these agent, intelligent, machine learning, artificial intelligence, all these, superficial intelligence stuff, it must be a control class in your class diagram. Okay? Whether you want to represent it as something, that one is different, doesn't matter lah, it's just a name. So same thing goes to this one. This is a simple one, the one that you are seeing now on your screen, validate customer. If I can relate with the iPhone, to validate a customer, you can have a thumbprint, your face, you have the passcode, all this passing another double, triple authentication. So it's huge. So that's why it becomes a one class. Okay. Alright, that's all. Any question? So what you have learned so far today? A basic sequence diagram. Alright, messages lah, basically a messages. I think the difficult part is about creating the classes up, the classes in the sequence diagram. And then the flow is not that. The flow is okay. For your project, your sequence diagram must tally with whatever you describe in the use case description. If I see your sequence diagram and then when I look at your description is not the same, this time is I will not ask you to redo, but I will say that I will deduct mark because you do not follow my advice in the class. Whoever going to do the sequence diagram. Hopefully, the other members help him or her because it's a lot. You simply come up with like 20 use cases and then that person has to come up with this 20 sequence diagram. And then he has to, if you change, okay, please let me know. You put there use case diagram update. Then I will refer your sequence diagram to them. But you don't have to submit sequence diagram, right? I'm not remember the next submission. There is one point that you don't have to submit to me. If it's too bad, then I will ask you to redo. If it's not that bad, I will keep quiet je lah. I tidak mark. Display message is the reply of register e-wallet button. Oh, this one. It is the reply means the line used by the user should be dash. Reply is a dash. Reply is a dash. Display is always this. Display message to the customer. Okay. Thank you, Moy. Oh, I can change that. Alright. This one, it should be. Wait, register e-wallet. Okay, click. Okay. And then validate customer. Okay. And then after validate the customer, you will check. Oh. Same thing lah. Search information and then it will reply back to the reply info, okay, and then it will register to this table, register your wallet, and then save display message to the customer, this one. Oh, kena submit week 8. Oh, week 8 lambat lagi lah. Thank you, Syafika. Okay, so this is, thank you, Moy. You are right. Should be dash and it goes back to customer. It goes back to the customer. The customer will see the display message. Registration is successful. Something like that lah. Okay. Any other question? So week 8, this one 6, 7, 8. Oh, lambat lagi lah. So we can start doing it.
Doctor, I have a question.
Yes.
If we are using external libraries in our system, does that also have to be control classes?
Yes, it's a control class.
Okay, thank you, Doctor.
That one is external library, not external system. External system is different. External system, as your actor, is different story. The process will be like this. The external library or library is always external. library or API. This one will be in the form of class. Like this. API is different. API is an external system. Depends on how big is the system. If it's small, then API, normal API lah. If it's a big, it's not. Any other question?
Hi, Doctor. I have a question.
Yeah.
Based on your explanation just now, you see that the written message can occur. I mean, the asynchronous message can have a written, right? So, based on the slide, the display message is the written from which one? Because I see the register e-wallet is a asynchronous.
So the question is?
So meaning from the diagram shows that the synchronous message can have a written message. Or am I wrong?
No. Oh, okay, I understand. I understand. Why do you say that? Okay, thank you.
Okay.
All right. Synchronous has written message. For example, search info and reply info. Correct? For this one, comes from here. Register e-wallet. The display message is a reply message for register e-wallet button. That's why I said it goes back to the customer. It's not go back to e-wallet registration page.
So meaning it can return from any other classes as well?
Correct.
Okay, understand. Thank you, Atta.
Yes, it can be written from any other class because it's a process. The classes is because it's a process to support the call message. So if you notice, this one async. This one async. This one sync. So if you sync, then the reply is a display message. Any other question? No more? So if you have no question, that's all for today. So we are going to have a tutorial this Thursday. However, for those in group 5, if you can join group 1, 2, 3 and 4 will be better because I will not be available at 11 o'clock. I have another urgent meeting which is compulsory, that one is higher priority than your tutorial class. So since tutorial already started at 9, hopefully you can join tutorial session on the 9 a.m. or the 10 a.m. one lah. If you have classes, then you only can watch the recorded video. Okay, and then at night you're going to have exam. Ada apa-apa nak tanya pasal exam? Tak ada. Good. Alright, that's all for today. Thank you very much. See you on Thursday.
Thanks, Doctor.
Welcome.
Thank you, Doctor.
Thank you, Doctor.